First, we need to prepare a clean syringe and a clean nozzle. The nozzle size is 100, 200, 300 micron diameter. Choose according to your needs. Manually assemble these two parts. Next, select the material we need to print. There are two polymer materials commonly used in the laboratory. This is PLA material. This is PCL material. This time, we will use PCL. Use the scope to scoop up an appropriate amount of material and put it into the syringe. Turn on the power and start the machine. Then open the lid. Then assemble the syringe with PCL material to the machine. And transfer the heater of the nozzle part. The temperature setting of the syringe is 190 Celsius degree. The temperature setting of the nozzle is 190 Celsius degree. The set temperature varies according to the material. Wait for a while to allow the temperature to rise to the set temperature, and melt the polymer material in the syringe. Turn on the pump, and set the air pressure during printing. Select the corresponding shaft according to the diameter of the stent we want to print. Common shaft diameters are 3 mm, 4 mm and 5 mm. This time we choose a 4 mm shaft for demonstration. In order to facilitate the release process of the stent from the shaft after printing, we will coat the top of the shaft with PVA solution as a sacrificial layer. After dipping an appropriate amount of PVA solution, lead and rotate it to coat it evenly on the surface of the shaft. Place it upside down on the foam board and wait for it to solidify. Assemble the shaft coated with PVA to the machine. After the initial fixation, use a wrench to further fix it. Turn the ejector pin to fix the two ends of the shaft. Start the program on the machine and click Print. This time extruder tool is used. Click Check and Shop to check whether the polymer material can be extruded smoothly. Click Next. Select the diameter of the shaft according to the situation. The shaft used this time is 4 mm. Turn on the computer and enter the password MNTL to unlock the computer. Click the corresponding program. And start the camera. Enter the rotation angle to adjust the camera position. For easy observation, click the Apply button, and the nozzle will automatically move closer to the shaft. Through the camera, can detect the distance between the nozzle and the shaft. Draw a straight line between the nozzle and the shaft. Through line measurement, we can check the distance between the nozzle and the shaft, and then control the thickness of the printed stent. Click the up and down arrows to fine-tune the distance between the nozzle and the shaft. We can fine-tune the distance between the nozzle and the shaft. Click the measurement. We can see the real distance. Select Next and select the corresponding printing program. Click the Start button to start printing. We can also adjust the printing speed. We can click the up and down buttons to adjust the distance between the nozzle and the shaft appropriately during the stent printing process. After printing is completed, close the camera program. And turn off the computer. Loosen the ejector pin and remove the shaft. Use a wrench to loosen the shaft and remove it from the machine. We can observe the printed stent. Immerse it in water to dissolve the sacrificial layer. Set the temperature to 0 degrees Celsius. Set the pressure to 0. Turn off the power of the machine. Turn off the pump. After the device cools down, remove the syringe and nozzle. After use, disassemble the nozzle and syringe. And place them in the used area for subsequent cleaning. After the PVA is dissolved, we can remove the stent from the shaft. Dry it with tissue and place it in a box to complete the production.